Hello friends, so till now we have solved two questions based on the application of Lamis theorem. In the first problem, we have taken two segments of a cable. In the second problem, we have taken three segments of the cable. But now in this problem, you can see here, cable is having three segments, but the third segment is passing over the smooth peg, or you can say the pulley. So first read out the question. Here, a light string A, B, C, D, E. Okay, so A, B, C, D and E, whose extremity A is fixed. So this one is a fixed part, has a weight W1 and W2 attached to it at B and C. So you can see here W1 and W2 are suspended from point B and C. It passes round a small smooth peg at D. So now this statement is very much important. It passes around a small smooth peg at D. Smooth peg means friction is zero. Okay, friction is zero. Frictionless, you can say. It is a frictionless. So it means mu is equal to 0. Because when you solve the problem based on the friction and the question is based on the belt friction, where the belt is passed over the pulley or cable is passed over the pulley, okay, so that time we have to use this formula T1 upon T2 is equal to E raised to mu theta. So mu stands for the coefficient of friction between that cable and the pulley contact surface. So T1 is tension on the tight side and T2 is the tension on the slack side. Okay, so now in this case mu becomes 0, so E raised to 0, 0 becomes 1, so T1 is equal to T2 in this case. So tensions on both sides of the peg or the pulley, you can say, is same in this condition because mu is equal to 0. That's why this statement is very much important. So carrying a weight of 300 Newton, so it is given over here at the free end E as shown in figure. So till now we have weight 1, weight 2 are suspended from point B and C, okay, and then the segment of a cable is passed over a smooth peg, okay, and it is also carrying a weight of 300 Newton at point E. If in the equilibrium position BC is horizontal, so this is horizontal, and AB and CD making 150 degree and 120 degree angle, you can see here these angles are mentioned over here with BC. Find tension in the portion of AB, BC, CD of the string and magnitude of W1 and W2. So now it is very much clear that these are the cable segments. So of course we are going for the calculation of tensile forces available in each and every segment. Okay, and same time we have to calculate the weights which are suspended from point B and C respectively. So I already told you the first step in the solving the problem based on the equilibrium or the application of Lamis theorem, you can say, is the free body diagram. Okay, so to draw FBD, first understand how forces are acting at each and every point. So first let me clear this. Now I'll start from point A. Let me just enlarge the figure. Okay, so now here at A you can see only one connection, so only one tensile force, and that will be away from the A, and cable segment is AB, so this is tension AB. Now I'll go to the point B, and you can see here now there are two cable segments, BC and AB are connected at point B, and weight is suspended, so weight is vertically downward, and this is unknown at this point of time. Now tensile force is away from the point B and away from the point B for the tensile force AB. So this is tension BC. Now we'll proceed for the point C, and you can see here again one more weight which is unknown to us. Then tension BC getting away from point C, and the tension in the cable CD. Okay, tension CD. Now I'll come to the point number D. So here this cable is passed over this peg, smooth peg. So mu is 0. I already told you there is no friction. So tension on both sides are equal. So here, if I consider D, the tension is getting away from here, and this tension is CD, and on this side this tension is E or DE, I can say. Just a minute, because this cable segment is DE, so DE, and that is equal to 300 only, that is equal to 300. Okay, because this, if I consider this point, then weight will act downward, which is 300 Newton, but same time it is connected to the cable, so one tensile force will act exactly in the opposite direction. So this 300 becomes TDE is equal to 300 Newton, and because of this TCD also becomes 300 Newton, because the tension on the both sides of the cable is equal, because it is a smooth peg, frictionless. And I told you, when mu becomes 0, this formula T1 upon T2 is equal to e raised to mu theta. If I want to implement this in this formula, then mu becomes 0, so e raised to 0 is equal to 1, and T1 upon T2 is equal to 1. So T1 is equal to T2, and therefore I can say TDE is equal to TCD. So now we have a value of TCD, and if you gone through this force diagram at each and every point, so it is very much clear that only at point B and C we are getting 3 forces in order to apply the Lamis theorem. So for the further calculation, we are just considering point number B and point C. Okay, so I'll draw separate FBDs for B and C like I did it in the previous problem. Okay, I hope this force diagram is clear to you in the given question that I have drawn. So now I'll start with the FBD for the point B. First I'll show the forces, and let me draw one horizontal axis and then the vertical axis. Similarly over here. So this is for the point B, and this is for the point C. Okay, for the B, W1 is vertically downward. Then you can see TAB is acting at a certain angle with the horizontal, that we will calculate later on, and this TBC is horizontal. This TBC is horizontal. Now if I draw FBD for the C point, then W2 is vertically downward, then this is horizontal TBC towards left, and this is TCD at certain angle. We will show exact angle while calculating the total angle between the forces. Okay, now I'll show the force names. So this is W1, this is TAB, this is TBC. Similarly here W2, then TBC, and here it is TCD. Now we'll calculate the total angle one by one. So the angle between these two is 90 degree, which you can do it by observation only. So this is 90 degree. Now here they mention 150. So if this is 150 and this is 90, okay, so this becomes 240. So the remaining angle becomes 120. Please cross check. 150 plus 90, 240. 240 plus 120 becomes 360. So I'll directly mention it over here. This is 150. And this is 120. Please cross check the values while solving. Okay, so 150, 90 and 120. Similar thing we'll do in the FBD of the C. So this is 90. This 120 is directly given to you, so there is no need of calculation anything. And finally the remaining angle, so 90 plus 120 is 210. So if I subtract these values from 360, so it becomes 150. So these are the FBDs for the point B and C, as we have considered point B and C for the further solution, because only these 2 points have three forces passing through it. So you can easily apply the Lamis theorem. So now we'll go further and apply the Lamis theorem. So now with which point you can start? Because I already told you to apply the Lamis theorem or to solve the problem using Lamis theorem, you must know at least one force value and all the angles. So of course, when you see this figure, all angles are known to you, but what about the force? Okay, so here I think at point B we don't have a value of even a single force, but at C we have already calculated. Here you can see this was a 300 which is connected to the cable, so cable carries tension equal to the 300, and same tension is on the other side because this is a frictionless pulley. So using this formula you can say tension on either sides are equal, so this is 300. So TCD we have already calculated while drawing the FBDs is 300. So we have a value of TCD which is equal to 300 Newton. Okay, so once again if you go through the FBDs, so it is very much clear that we have to start with the point C. You cannot start with the point B because all forces are unknown over here, and here we have a value of one force, that is tensile force in a cable segment CD. So now if I apply Lamis theorem, over here I'll start with the known value, that is 300, divided by the sine of angle between other two forces. So if I consider TCD, then the angle between other two forces is 90, so sine 90, and sine 90 is 1. Then if I consider W2, then W2 will W2, then other two forces are TBC and TCD, so angle between this is 120, so sine of 120, and finally the TBC, so TBC upon sine of 150. Okay, so if you see here, then sine 90 is always 1. Okay, sine 90 is always 1. So here equation becomes, for the W2 I'll write, if I equate these two fractions, then W2 is equal to 300 into sine 120. For better understanding, I'll mention here sine 90 is equal to 1. Okay, so idea is clear to you. And for TBC, it becomes 300 into sine 150. So if you calculate this, you will get the values of W2, that is weight suspended from point C, and the tension in the cable BC. So first 300 into sine 120. So the answer is 259.80. Always go for the 3 digits after decimal place. and then is 300 into sine 150. So answer is 150 Newton. Okay, so now we have a value of TBC which can be taken further for the calculation while applying the Lamis theorem at point B. So this value is now known to us and this is equal to 150. Okay, so now I'll apply Lamis theorem over here now. So it will be, I'll start with the known value. Okay, so it will be 150 upon sine of angle between other two forces. So this is sine 120. Okay, TBC if I consider, then these two forces, so the angle between this sine 120, which is equal to, if I consider W1 first, then W1 upon angle between other two forces, that is 150, so sine of 150, which is equal to the remaining force, that is TAB, divided by sine of angle between other two, so sine 90. Okay, so if I equate this two first, 150 by sine 120 is equal to W1 by sine 150. So my equation will be for W1 is 150 divided by sine 120 into cross multiplication, that is sine 150. So if you calculate this, 150 divided by sine 120 into sine 150. So answer is 86.602 603 Newton. Okay, and for the TAB the equation will be sine 90 is 1, we have already known this. So equation will be sine 150 divided by sine 120. So you will get the answer. Sine 120. Just a minute. Okay, sine 150 upon sine 120, because this value is 1. So now if I calculate 150 divided by sine 120, so this is 173.20 205 Newton. So here now we have a values of W1 and W2. So W1 is 86.603 Newton. Then we have a W2 which is 259.807 Newton. Then they ask for the tensile forces in each and every segment. So we started with the TCD, correct? TCD, which was the first value that we got, and TCD is equal to 300 Newton. Then we have a TBC, which is equal to 150 Newton. And finally, we have a value of TAB, which is equal to 173.205 Newton. So these are the final values as per the calculations. So guys, please solve on your own and please cross verify the values that we have calculated here. And if you find any kind of difficulty in understanding, just let me know. I quickly revise the whole problem. See here, first we have gone through the question and understood the question, and then according to the given conditions in the question, we draw force diagram, okay, at each and every point in order to apply the Lamis theorem. So after drawing force diagram, we came to know that only B and C can be used for the further calculation for applying the Lamis theorem. So we completed the FBDs at point B and C. We have shown all the angles and all the forces required to apply the Lamis theorem. Then we started with the C point because tension CD is known to us. So we started with this C point. Once we get the value of TBC, we used in the point B and solved the unknowns like W1 and TAB at point B, and these are the final answers that we have got. So I feel guys, most of the doubts are clear here because this is the third problem that we are solving on the application of Lamis theorem. Please go through all this question and try to understand each and every step and implement accordingly, understand the questions and get the correct solution. So guys, now we'll proceed for the next question, which is again based on the Lamis theorem and which was asked in your SPP University for the 5 marks. So let's start with the next question, and question number 4.